That's weird. Every time I get on Zoom, the settings get changed through no fault of my own. I have people in the waiting room. I used to have it set to admit before meeting, and that setting got changed. How stupid. How do I probably can't change it from here. That's ridiculous. So now I have to just admit. Welcome to AP Physics. We'll start in a few minutes. Here, I gotta turn up my volume. Hey, Everett. Hey, Everett, could you, let me see here. I'm gonna unmute you. Oh, come on, unmute. Wait, there we go. Okay, Everett, talk.
Mr. Shana.
Hey there.
Hi, Mr. Shana.
Where the heck are you? Oh, there you are. Yay. Okay, so I'm able to hear you. That's good. Are you able to hear me?
Yes.
Okay, good. Boy, things are really laggy. All righty. Well, then, hey, we'll start in a couple minutes. I gotta remember to look at the camera, not look at the screen. Yeah, look at the camera. So my eyes are boring into you guys. Oops. 5 people are waiting, admit all. Yeah, and you guys don't have to have your video. I'm having my video screen so that you get this illusion that we're all together. But the fact is, you don't have to have. Oh, that's another thing. Hey, would you be able? Is it easy for you guys to change your name so that it's your first name and last name, or even better would be like last name and then first name, like last name comma first name. I'll send an email about that because I'm going to have to record who all actually attended. Even though attendance isn't mandatory, we want to record it just to make sure that we're getting everybody, So here I wonder why I got that stupid waiting room going on. I had it set, I made the settings so that there was no waiting room. I allow students to join my classroom early, but somehow miraculously that setting got changed. So I'll have to change it back after our meeting. Yeah, I don't know. Everett's network bandwidth is low. Yeah, if you have a dial-up modem, then you're not going to be able to play Call of Duty very well. All righty. Oh, I got 2 people waiting. So it's not gonna, stupid thing. It's putting everyone in a waiting room instead of just letting you join immediately. Boy, what a huge hassle. I don't know if I can change the settings during a meeting. See if I can do that. Doesn't look like it's letting me change it from here. I'd have to change it in my settings, and I don't know what that would do to my meeting. It would probably just freeze it or something. I'm going to give another couple minutes for everybody to come on, and then we'll start. And I want to, let me see here. There we go. Hey, Ben. And I want to remind everybody again that next time, if you could have your screen name be your last name first and then your first name, like, Shaw, comma, Shrey, that sort of thing. then that would help me do the take roll thing. How many participants do I have? 30 participants. Oops, admit all. Okay. Thirty-one participants. Shreya, waiting. Okay, hey kids. Let me see, what is there anything I need to tell you? Yes. First of all, this week is a week where we're going to try to get good at doing these block scheduling classes thing. And one thing they want us to do is have you guys check in every day. Meaning, like, I guess what I'm going to do is I'll have an assignment on Google Classroom every day, and it'll just say, like, check in 4/8. That'll mean tomorrow. You just have to go on Google Classroom and just, I don't know, type "I'm fine" or something like that. They want to make sure that we are in touch with you guys every day. I think not for scholastic reasons, but for emotional reasons. So if you could do that, if you could type in, every day, and I don't have it set up for today because I figured we'd be doing this today, but starting tomorrow, there'll be every day that we don't meet, there'll be a check-in on Google Classroom, and you'll just check in and say, "I'm fine," or "It's a bummer," or something like that. Okay, let me think. Uh, I guess, are there any questions? It's really weird for me not to hear anyone. I think you can, or you're able to unmute yourselves. Does anyone have any questions? There's only 32 participants. Go ahead. Robert?
Oh, okay. So will the grades that you have in the grade book right now stay for the 12-week grades, or will it go back to March 15th and whatever we had in March 15th?
Well, here's my problem. I have not completed all of the grading up to March 13th. So like your chapter 18 exams, your homeworks, your labs. And so when I get all of that graded, which I'm going to do right after we're done here together, when I get all that grading done, then I'll put everything on School Loop, and that's going to be your 12-week grade, which is your grade that's caught up through Friday, March 13th.
Okay, but I also had a question because there's like
Yes.
some assignments from like March, not for your class in particular, but like other classes.
Yes.
So if they have it in like an assignment from March 20th, will that be kicked out or will that stay in?
Yeah, supposedly it will be kicked out.
Okay.
Supposedly your 12-week grade should only be assignments assigned and due through March 13th.
Okay. But it'll
Our
still
last
come
day.
back afterwards as long as it doesn't bring your grade down.
Yeah, exactly. And that's another thing about the grade is whatever your March 13th grade is, your grade cannot go lower than that.
Is this for all classes or just your class?
All classes. This is decreed by the district. Yeah. So whatever your 12-week grade is in all your classes, like, so if you got all A's on your 12-week grade, that's it. Just don't do anything, right? Just shut it down because you're going to get all A's. So it's sweet. So if you're the type of person like the ant and the grasshopper, if you're like the ant who planned ahead and put everything aside for the future, you win, right? Just enjoy your quarantine. Well, I'm kidding, of course. You should prepare for AP exams and stuff like that and, be good and stuff. Anything else?
If our grade can't go down, does that mean we're still gonna have a test?
Yeah, because people's grades can go up. So I'm going to give you the test. Plus, I feel this obligation to teach you things and have you learn stuff. And so I'm giving you the test, but I don't know, but it's certainly, if you have an A as of 12 weeks, then you're essentially doing the test with no pressure. And so it's kind of an experiment, do kids perform just as well when there's absolutely no grade pressure,
Gotcha. So let's say we do worse on the test than
Mhm.
like our test average. What happens?
Well, your grade would go down, so on School Loop, your grade might say, I don't know, B or something like that. But the fact of the matter is your semester grade, if you have an A after 12 weeks, your semester grade cannot go lower than an A.
Got it.
So, yeah, so it's kind of a weird thing. Yeah, I mean, you can see what grade you would have had, but actually, if you have an A after 12 weeks, it can't go lower than A.
Thank
Yeah. Any other
you.
questions?
There's
Yes, Ryan?
Does that oh, I had a question.
Yes, Jaslyn?
Does that have anything to do with like how in School Loop there's like a second percentage? There's like one in parentheses.
On my particular School Loop or some other people? I don't know. I don't know what that's talking about.
The second percentage is like the change.
It's just shows how much your grade changed from the last time they inputted grades. So if you went positive, your grade went up. If a negative, your grade went down.
Okay.
Oh, good for you. I ignore all of that. I didn't even, Jaslyn, I frankly didn't even know what you were talking about. And I'm glad other students.
Okay.
paid attention to that. Yeah. I just look at your points. Any other questions or issues?
Yes, me. Okay.
Yes,
So
Ryan.
since there's like obviously like no talons, are there going to be any like extra credit opportunities or no?
Yeah, I need to do that, right? So I haven't figured out how I'm going to do it because, frankly, I envisioned giving us a lot more opportunities to get together than what we're being given now. I'm essentially, I'm going to spend about 45 minutes on Tuesday and 45 minutes on Thursday, and that's it. That's my only actual contact with you guys. So now, I was going to give you the extra credit as being where we're together in some long session and you're doing AP problems. But I may have to do that sort of thing where you will do the extra credit. You'll do essentially free response questions on a separate sheet of paper and then post it on Google Classroom. And then I'll look at that and give you like 1 point for every problem or something like that. So yeah, there will be extra credit for preparing for the AP exam. The only way to prepare for the AP exam right now is to do free response questions, no multiple choices, and I'll give you like a point or whatever. I'm not sure yet. I got to figure out the math, but I'll give you a point for every free response question you do. Any other questions? Yes, Ryan, again. No. All righty. Well then, hey, let's complete our chapter 20 thing. Right now, tentatively, we're gonna have our chapter 20 exam on Tuesday. It'll be at 12:30. It'll be an abbreviated version of the exam, and because you have to be able to do it within 45 minutes, and that's it. I'm still planning on Tuesday, but we'll see. Now I'm just going to leave it open to you guys. Are there any questions or issues on any of the homeworks that I've assigned?
Where would we take the exam?
You would just take it at home like you are now. I would send you a document, which is the exam, and then we'd say ready, set, go, and then you would just do the
So
exam.
we just so we do it on a separate piece of paper and then like take a picture and then send it or something?
Absolutely.
Oh, okay then.
Yeah. I think that's what we'll do. I don't know. I have to think about it, or maybe, maybe I would just have you do the exam on your own time whenever you want to, except then, of course, you start getting that test security thing. I mean, one of the main ways that the AP exam is going to be able to ensure test security is everybody on Earth is going to take their exam at exactly the same time. you know? So we on the West Coast, we're going to take it at 9 a.m. People on the East Coast are going to take it at noon. You see that sort of thing. And so that would be the only way I could, you know, at least have some test security would be to you know, have all of us do it at the same time. And the logical time would be when during our meeting time at 12:30.
So it's gonna be in a time interval. Like we're gonna have a certain those 45 minutes to complete the test.
Correct. Yeah,
Okay.
all 70 of you would do it simultaneously. You'd have 45 minutes and then you would take a picture and upload it onto Google Classroom.
Wait, so like we do it during the Zoom meeting and like, I don't know, like on camera or something, and then we just like do it in front of you?
Yeah, supposedly
Oh, okay.
that's like the best way to do the security test security thing. Oh, Brianna, welcome.
Yeah.
Um,
Oh, hi.
but anyway,
Yeah. I'm
yeah,
in
you
Mr.
remind.
Edwards Zoom too.
What's that?
I'm in Mr. Edwards Zoom too on my MacBook.
You really? Oh, good for you. You're doing 2 Zoom meetings simultaneously. You're awesome. Oh my God, that's like my son. He'll play poker online and Call of Duty simultaneously. You know.
also require you to, kind of show what you've learned throughout the course of the
What?
year.
What's that?
Questions, kind of.
Oh, sorry, it's him talking.
Oh, is that Mr. Edwards talking?
Yeah.
Oh my God. So yeah, so I don't know how many of you have 2 science classes that are going to meet simultaneously, but all I can tell you is this one is recorded. So anything that happens during this 45 minutes will be recorded. I will upload it to YouTube and I'll provide a link.
Okay.
So you never have to worry about. The only thing you'll miss is your ability to ask questions and give your 2 cents. But yeah, I record every Zoom meeting and then post it.
When I find out.
Okay. Thank you.
Yeah, you're welcome. Yeah, good. Go ahead and
Bro.
mute Mr. Edwards too. Yeah, Ryan.
Kendall just texted me. She said she's trying to join, but like it
Oh,
says you'll let her in
damn.
soon.
This stupid Zoom. Can I just tell you how suck technology is? So I have the settings saying students can join the classroom before the class starts, and somehow administration has changed the setting on me. So now I have to, and of course, unbeknownst to me, so I have to go back in the Zoom settings and go click, oh, please let the students join before it starts. Anyway, yeah, technology sucks. Any other questions or issues before we start actually addressing actual, physics problems?
For the test, are you gonna give us a Xerox like normal, or how is that gonna work?
Yeah, you mean a review Xerox?
Yeah, review
Yes, I actually posted it on School Loop calendar. It's actually literally our last assignment. Assignment number 41 is the last homework assignment that we're going to have. Every other assignment after this is going to be sample AP exam problems. So yeah, so that's it. That's the review Xerox. It's assignment 41. It's on School Loop calendar.
Okay, thank you.
You're welcome. That's my wife behind me.
Did you know you said the D word?
Did I say the D word? What D? The damn word? That one? Don't cuss. I'm not supposed. And this is being recorded too, so people will know that your teacher says damn. Okay, I won't say it anymore. My wife says don't say it. Okay, so hey, anything else that doesn't involve doing physics problems? All right, then cool. Then here's the next part of our little time together. And I've got about, I actually allotted you guys until we started at 12:30. So we're allotted until 1:15. So are there any questions or issues on any physics problems? Any of the Kirchhoff's law problems? Anything like that? I don't have anyone trying to get in anymore.
Can you do number 32 on assignment 40?
Yes, Naomi. Number 32 on assignment 40. Yay. Let's see what that looks like here. Number 32. Okay. I'm going to try to Number 32, correct? You say.
Yeah.
Okay, I'm gonna try to do the screen sharing, which is always you're really always rolling the dice when you do screen share. A plugin is required to share an iPhone iPad. I didn't need this plugin yesterday. I shared an iPhone iPad yesterday, but now, oh, a plugin is needed. Okay. Stupid thing. I'm trying to access the mirror, screen mirroring. Okay. All righty. So Naomi, you see number 32 right there? What the heck?
Yeah, I see it.
Okay, great. So the ideal batteries are 10 and volts, and the other one is 0.5 times the other voltage, which makes it 5 volts. I don't know why they expressed it that way, but the other one is 5 volts, and the resistances are 4 ohms each. What is the current in resistance 2 and resistance 1? Okay, this is a Kirchhoff's loop law, Kirchhoff's current law problem. So I'm actually going to go through the process of doing Kirchhoff's laws. Maybe I'll actually do it on the problem itself. Okay, this is 10 volts, and this is 5 volts. Okay, are you able to see that? Okay, 10 volts and 5 volts, and then this current I'm going to call I1. This current through R2 I'm going to call I2. And then this current through R3, I'm going to call I3. And I have the currents directed in the way that I'm showing, okay? So the next step, according to that Xerox I gave you about how to do Kirchhoff's laws, once you've defined your currents and defined their directions, you've got to list the voltage drops across the resistors. I'm going to call this voltage drop V1, and you'll notice I put the plus on the left side and the minus on the right side because the current is entering R1 on the left and exiting R1 on the right, which means the voltage to the left of R1 has got to be bigger than the voltage to the right of R1 because this charge is giving up energy as it passes through R1. It's lighting a light or turning a motor or doing something that requires a loss of energy. And the same thing happens with R2 because I2 is traveling through R2 from left to right. My voltage drop is going to be from left to right. That is, the entrance of the resistance is going to have a higher voltage than the exit. And the same thing with R3. That's the plus and that's the minus of V3, which is the voltage across R3. Okay, that's step 2. Step 3 is now to write Kirchhoff's loop rule. And Kirchhoff's loop rule says you start at some point. I'll define this point here as point A. You choose a loop. I'm going to choose the leftmost loop, and I'm just going to go clockwise and have all the voltage rises equal to the voltage drops. And so, or another way to say it is just have your voltage rises be positive and your voltage drops be negative. I forget which way I say it in my little lesson. So starting at A, I've got a voltage rise of 10 volts. I'm going to have the rises equal the drops. So I have 10 volt rise, and then the current goes through R1, and I'm going to have a voltage drop, and that's going to be I1 R1. And then I3. What's that, Ryan? Oh, you want the keys to the office? Okay, no problem. Yeah, this is it.
To get into both the deadbolt.
Yeah, well, I don't ever lock the handle, so just the deadbolt. Oh, well, then that's the handle, yeah. Alrighty. So looking at this loop here, I have a voltage drop of I3 times V3. So I3 times, R3. And then finally, I come back to point A. So this is one equation. Okay. And now I'm going to choose another loop. I'll choose the rightmost loop. And I'll just start at some point. I'll start here at, let's say, this point here. I'll call it point B. It doesn't matter. And now I'm going to go clockwise again, but I could go counterclockwise if I felt like it. And then the voltage drops go on the right side and the voltage rises are on the left. So from B, as I go clockwise, I have a voltage rise. I3R3, which is V3, is a voltage rise. So I3R3 is a voltage rise. And then I2R2 is a voltage drop. I2R2 is a voltage drop. And then this 5 volts is a voltage drop. Because as I go through here, as I take my path clockwise, I go from a positive to a negative, so I'm losing 5 volts. Then I get back to B. And so this is another equation. All righty. And there are 3 loops: the left loop, the right loop, and the entire loop. It looks like I froze. Nope, oh, here we go. Now I'm going. There's 3 loops: the left loop, the right loop, and the entire loop, but you only need 1 fewer than that number of loops. And now finally, I'm gonna do Kirchhoff's junction rule. And Kirchhoff's junction rule says choose a node. I'm gonna choose that node right there, and where R1, R2, and R3 meet, and have the current going into the node equals the current coming out of the node. So I1 is entering and I2 and I3 are exiting. Okay. So Naomi, are you okay with these 3 equations with 3 unknowns? Wait, Jerry Fang has entered the waiting room for this meeting.
Oh yeah.
Okay, so Naomi, are you still there? It was you who was asking, right, Naomi? Did I lose Naomi? Did I lose everyone?
I'm still here.
Okay, you guys are still there? All right.
Yeah.
Well,
Yeah, I'm still here.
okay, good. But Naomi, weren't you the one who was asking about it? Did I lose her? Did her internet connection go haywire?
I think something's wrong with my internet. I keep going out and coming back in.
Oh, there you are. Yay. Okay. Thanks, Naomi. Yeah, I know. Like I said, you can quote me on this. Technology sucks. Technology's a lie. Okay, so anyway, I've got 3 equations with 3 unknowns, right? I don't know what I1, I2, or I3 are, so you're gonna have to solve these 3 equations with 3 unknowns somehow, you know? One way to do it is with matrices, but the thing is, on the AP exam itself, before COVID happened, all they wanted you to do was be able to make the equations. They didn't care if you could actually find the current. They just wanted you to make the equation, okay? Oops, I lost my camera because my iPad shut off. Okay, so is that good? Wait, no, I may have to turn off and turn back on the screen share. Yeah, okay, here, just 1 second. I have to turn off and turn back on the screen share because when my iPad turns off automatically, the screen share gets confused and just stops doing it. So here, just a second, I'm gonna do screen share again. Boop. Boop. Okay, so there's the 3 equations. The way I would set it up would be like this. I would take this first equation and call it I1R1 plus, rather I1R1 plus I3R3 equals 10 volts. And then I've got I2R2 plus I3R3 equals 5 volts. And then finally, I've got I1 plus I2 plus I3 equals 0. So I've got 3 equations with 3 unknowns, and I'm trying to think of a convenient way to do this. I think what I would do is I would take the first equation and subtract off the second equation. So I end up, and by the way, all of the R's are 4, right? Every single resistor is 4, I think they say, right? Yeah, the resistances reach 4. So I would combine I would subtract the second equation from the first equation. So I get 4I1 and then minus 4I2. These two guys cancel and I end up with 5. And now I've got one equation with two unknowns. And then I would, oh wait. No, I wanted two equations with two unknowns. So then I've got 4, oh man, I'm so sorry. Equals 5. And then I've got I1 plus I2 plus I3 equals 0. And again, I would get rid of I3. And so I would multiply this equation by -4. So I get -4I1 minus 4I2 minus 4I3 equals 0. And, oh, wait. Wait, what did I do here? No, this should be a minus. Oh my God, I'm screwing this up royally. So I'm going to multiply by +4. So that's 4. Okay. And now I'm going to combine these two. And I end up with 4I1. Everything cancels. 4I1 equals 5. And so I get I1 equals 5/4 of an amp. Okay, well, anyway, that you just, however you can do your, here, let me get that up. However you can do your algebra 2, but I got my I1, which is 5/4 of an amp. And then you can plug that into here and you end up with 4 times 5/4 minus 4 times I2 equals 5. And then that becomes 5 and you end up with I2 equals 0. So I don't know. Hey guys, I'm just merrily doing my stupid algebra, but you've got 3 equations with 3 unknowns. You'll have to solve it however you want. But the fact of the matter is, on the AP exam and on my exam, I do not expect you to solve that. I just say, give me the equations and that's good enough. So any questions or problems on that problem? This was problem number 52. Oh no, problem number 32. Yeah, this was number 32. And the important part of that problem, again, was getting your loop rule equations and your junction rule equation. Beyond that, I'm not going to expect you to do anything else. So hey, anything else?
Can you do number 31 on assignment 40?
Yeah, it'd be my pleasure. Let's see 31. Okay, 31 is not a Kirchhoff's law problem. 31 is one where you just have to use your you know, kind of a Sudoku sort of thing as you go around. So let me see if I can do that right here. And okay, so here's 31. They tell me, okay. So they tell me the current in resistance 6 is 1.4 amps. So I've got 1.4 amps going through resistor 6. And the resistances of 1, 2, and 3 are 2. So this is 2 ohms, 2 ohms, and 2 ohms. And then resistor 4 is 16 ohms, and resistor 5 is 8 ohms. So this is 16 ohms, and this is 5 ohms. And then resistor 6 is 4 ohms. What is the EMF of the ideal battery? What's the EMF of the battery? And so I would actually not even get the equivalent resistance. I would just go around and doing Sudoku, you know? So for example, I've got 1.4 amps going through a 4 ohm resistor, correct? So do you see that that makes the voltage drop 1.4 times 4, you know, V equals IR, so that'd be 5.6 volts. So this resistance here is going to have a 5.6 volt drop across it there. In addition, since 1.4 amps goes through R6, 1.4 amps must also go through R5, and that's a 5 ohm resistor. 5 times 1.4 is 7, so I'm going to have a 7 volt drop across that 5 ohm resistor, which means the voltage of this voltage here is 0 volts because that's the negative terminal of the battery. then it's going to be 0 volts everywhere, wherever a conductor is connected to the negative terminal of the battery. Well, 7 plus 5.6 is 12.6 volts, right? So this is going to be 12.6 volts. And so now I can find the current going through R4. The current, let me get my calculator, just 1 second. Since I have a 12.6 volt drop across the 16 ohm, whoops, I lost my camera. Okay. All right, I lost it, but that's okay. Maybe it'll catch up. No, it won't. Okay, just 1 second. I'm going to stop the screen share and then bring it back. Just a second. I got to set my iPad to not turn off automatically. Just, you know, I don't want it to save batteries. I want it to not turn off. Okay, so I got 12.6 volt drop across the 16 ohm resistor, which is 0.7875. Okay, so the current going through the 16 ohm resistor is 0.7875 amps. 0.7875 amps. All righty. And since I've got 1.4 amps going through the R5 and 0.7875 amps going through R4, that must mean the current going through this 2 ohm resistor, the current going through R2 is going to be the sum of those two currents. So I'm going to have 1.4 plus the 0.7875. So the current here is going to be 2.1875. Okay. And so now I can find the voltage drop across that 2 ohm resistor. And I'm going to multiply the 2.1875 by 2 to get 4.375. So the voltage drop here is 4.375 volts. And my drawing is starting to get pretty cluttered. But so I got 4.375 volts, which means the voltage here has to be 12.6 plus the 4.375. So 16.975. So the voltage here is 16.975. That's a voltage right at that node, the node between R1 and R2. And finally, since that's 16.975 and this is a 2 ohm resistor, I can get the current here because it's a 16.975 volt drop, only 2 ohms. So that's going to give me like 8 ohms, or rather about 8.5 amps, about 8.5. I'm going to call it 8.5. So the current here is 8.5 amps. It's 8.5 amps because it's a voltage drop of about 17 from the node in between R1 and R2 and the 2 ohm resistor, and the 0 volt place. And so that's 8 amps, which means the current going through this resistor here has to be the sum of the, how many amps is that? 2.1875? 2.1875 plus 8.5 plus 2.1875. So I got 10.675, about 10.7 amps. So I got about 10.7 amps going through the 2 ohm resistor, which means the voltage drop across the 2 ohm resistor is approximately 21.4 volts. And so I've got to add the 21.4 volts to the 17, and that's going to get me about 38.4 volts. And wait, 21, no, 21, yeah. Oh, it says 48.3. What, did I do something wrong? Uh-oh. I should have used a bigger drawing. Something went wrong somewhere, but oh well. Yeah, I should definitely have used a bigger drawing. So I got a wrong answer. And so somewhere here I made a mistake, and I don't know where my mistake is. But that's your process. Your process is just doing a V equals IR and then just doing Kirchhoff's junction rule to get each thing. And I don't think I'm gonna try to do it again, but I don't know. Does that make sense? Is that good enough even though I messed it up? Because obviously I was writing so small that I just screwed something up.
Yeah, that makes sense. Thank you.
You're welcome. Yeah, but what really characterized problem number 31 is that, you don't have to get the equivalent resistance. You don't have to get the current out of the battery. You don't have to do any of that stuff. You just work your way around the circuit. If I had another session, I would make a much bigger drawing and do it with the much bigger drawing, but this is our only session, so oh well. Hey, any other questions or issues?
Number 79 on homework 39, but I only need part C.
Number 79, part C. Let me see what I got here. Now I'm looking at the online version of my book. Number 79. Okay. Oh yeah, that's a Kirchhoff's loop law problem. Here, I'm not gonna make this mistake I made on this problem. Also, I'm gonna have to get out of the screen share and back in because it's just way too laggy. That screen share is supposed to be like one of the big positives of Zoom, but I don't think it's that big of a positive if it keeps screwing up. Okay. All right. Well, no more lag. So here comes 79. Hey, Claire. That's my daughter. She just woke up. What is that, 109? She just woke up. We have summer schedule now. We all go to sleep really, really late. What is that, 5, 8, 30 volts, 27 ohms, 10 volts, and 12 ohms. Okay, great. And they ask, consider the circuit, determine the magnitude of the current in the circuit, the magnitude of the voltage between the points labeled A and B, and state which point A or B is at the higher potential. Okay, let's go ahead and do it. We're going to define this current as I. Every resistor is getting this current I. So, oh, now I'm lagging a lot again. And I just chose I at random. And so as I goes around the circuit clockwise, this is going to be a voltage drop. This is a voltage drop. And then this is a voltage drop there as the current goes around. And so now I'm going to do Kirchhoff's loop rule. And I'll start from what they define as point A, which is right there. Here's point A. And so I'll start at A and work my way clockwise. And so starting at point A, I'm going to have the rises equal the drops. And I'm really lagging now. But anyway, I've got a rise of 30 volts. And then I have a drop of 27I. Because the current going through this resistor is I. Here, I'm going to have to, oh, I see my stupid iPad turned off. Wow, I really need to change that setting. I don't know why I've never done it before. Okay, I'm gonna have to get out of screen share and back in. Just a second. All right, well, look at that. The magic occurred. Okay, so, all righty. So I've got a 30-volt rise, and then I've got a drop of 27I, and then I've got a drop of 10 volts. So here's 10 volts on the drop side, and then I've got a drop of 12I. All righty. Why is this? Oh, okay. It seems like it's focused more than it used to be. That's weird. Anyway, and then I've got this voltage drop here. So that's a drop of 8I. So plus 8I. All righty. And then I've got a drop of, wow, that didn't work out. Here, let me write it over. So I got a rise of 30 volts and everything else is a drop. So I got 27I plus 10 plus 12I plus 8I plus 5I. So I'm going to get 20 equals 39, 47, 52. So I got 20 over 52 amps equals I. So that's what I'm getting is the current. Okay. So here's the thing. And here's the answer to your question. And who's it? Was it you, Zong, who was asking this question?
Yeah.
Okay, so the answer to your question is what direction is the current going? Well, since I guessed, just randomly, I guessed that the current would be going clockwise. And wait. Yeah, I guessed that the current would be going clockwise. And because my I is a positive answer, I guessed correctly. If my I was a negative answer, then I guessed wrong. You know what I mean? So that's how I know that the current is indeed going counterclockwise. And so here's point A. And here's point B. And so starting from point A, there's a 30-volt rise, and then there's a 27 times 20 over 50 volt drop. So I got 27 times 20 divided by 52 rather. So I got about a 10.4 volt drop, and then I'm at B. Okay, so since I had a 30-volt rise and a 10.4 volt drop, then the net voltage rise is 19.6. So from point A, I gain 30 and lose 10.4, and then I'm at point B. So that means that point A is higher voltage than point B, because point A, whatever point A is at. Oh, wait, no, never mind. No, I'm so sorry. I was getting it from here. Just a second. No. So I'm at point A. I rose 30 and then lowered 10.4. So it's still a 19.6 volt rise. So if point A, if I designate point A as 0 volts, then between point A and point B, which is the same as here because it's connected by a conductor, from point A to point B, I gained 30 volts and lost 10.4 for a net gain of 19.6 volts. And they ask, which point is at the higher potential? B is at the higher potential. B is 19.6 volts higher than A because your charge at A gains 30 joules per coulomb of energy, then loses 10.4 joules per coulomb of energy for a net gain of 19.6. So is that okay with you, Zahn?
Got it.
Yeah, so yeah, you gained voltage, so that's it. B is at a higher voltage than A. And at this point, I'm going to have to shut it down as far as physics questions. Does anyone have any last question about the class itself, either grading or schedule or anything like that?
Are you gonna post the last Zoom today?
The last Zoom, you mean the one we had last Thursday?
Yeah.
I'm embarrassed to say I thought I did. If I didn't, then that's my bad. Wow, I thought I posted it, and didn't I send you a email telling you how to find it and stuff?
Oh, I'll check again, but
Maybe I have. Well, if I haven't, I will. I'm so
Okay.
sorry. I thought I actually did that like Friday or Saturday, but I'll check because it's possible that I didn't. I have to tell you, you'd think that being in quarantine, like, you know, your life would be easier or something, but I find my life is much harder in quarantine. You know, having to deal with food and everything. It's just weird. So yeah, I end up messing up. Any other questions? So yeah, I'll make sure that this session and the last session we had will both be posted, and I'll provide links for them. Anything else?
Are you having a another Zoom meeting on Thursday? Or
Yeah, we'll be meeting at 12:30 every Tuesday and Thursday, utilizing the block scheduling that the district has decreed.
Oh, okay. All right. Just wanted to make sure.
Yeah. So I'll send you an email with the password and ID number for our next Zoom session.
Okay.
Yeah. Anything
So
else?
after we're finished with this test, are we gonna start doing AP practice?
Absolutely, yes.
All right.
Cool. Yeah, nothing but free responses.
Oh,
All right,
Mr.
kids.
Shana,
Yes,
just
Jerry.
a quick question. So, what we're doing on circuits right now, they're not going to be on the AP test, though, right?
That
It's
is
just
correct.
us. Okay, I see.
Yeah, I'm just having you do it just so that you had a good class.
Okay, thank you.
Hey, you're welcome, Jerry. Anything else? Alrighty then. Hey, good luck, you guys, and you may now commence leaving our little meeting, because I'm going to end the meeting now. Bye-bye.
Thank you, Mr. Shane. Have a good day.
Bye. You too.
Bye,
Have a
Mr.
good
Shane.
day, guys.
Bye, Mr. Shana.
Bye.
Bye. Good luck. Good luck, Julia. Yeah, you kids. Man, this is brutal. Bye. Bye, Everett. Okay, I'm going to end meeting now. End meeting.